It's 422 right here, data integrity, folks. Our lesson right here is to understand data authentication validation, practice hashing techniques, and validate and authenticate data using hashing. So open up this resource lab, and I'm going to explain what's going on here. So this is really about like your big picture here is how do we verify that data hasn't been changed when it's transferred? Like if maybe you send something across the internet. How do you know that the file that you sent to someone is authentic and came from you? How do you know it wasn't changed in between? We talked about before, there's something called the man in the middle attack. If someone intercepts your data, alters it, and then just sends it to its intended target, but they put something in there, how do you verify that they didn't put anything in there? Or how do you verify if a file that you think is supposed to be that file, like, oh, your regular some document didn't get changed by some kind of virus or some other person that got into your computer. So we can do a few different things to authenticate data. So when you receive a file from a friend, you can verify it. You'll need to not only think about who sent the message, but also verify it's in it's an original, unaltered form. Yeah, it's not just getting it, but that no one changed something in there, right? Especially if it's like dealing with numbers or a contract and stuff. Like you want to have some way to validate those kind of things. So how we authenticate is something called using hash functions. So or it's called hashing. So it's a computational process that converts data of a varying size to a fixed size. So maybe you have a big file. I can convert it down using some math formula in the background. Oops, my video's starting to spaz out. So I'm going to stop my virtual camera. Oops. I think it's going to help. So sorry, I'm going to change my camera. Oh, then you can't see my face. Hold on. Okay, I'm hoping it doesn't lag anymore. We'll find out. If it lags, let me know. But hash functions are ideas that you can use these to take data of any length and turn it to a fixed length. So in the previous lesson, we actually did hash values. We used those to crack a password, right? We had to turn our encrypted container into a hash value, and then we could like analyze that one to figure out what the password was. So here we're going to use hash functions to ensure data validity. Hash function creates a fixed size thing, and representation represents some unique data. Minor change in the data results in a different hash value. So here's an example. What if we had these sentences here? The quick brown fox could convert to a hash value of these 4 bytes. And bytes are basically 16. Remember hexadecimal? It's the numbers 0 through 9 plus A, B, C, D, E, F. So it's like 16 digits. So the one way to hash this, in one algorithm that does this, is it takes a sentence like this and it converts it to this. But then if you add quick brown fox jumped over, it would convert it to this hash function. Or if you added lazy dog's back, it converts it to this. So these would be a unique hash function that this sentence, through some math in the background, converts to this line. Now you might be like, whoa, how does it do that? And it's doing it through some math. I can't explain it right now, but some math stuff's going on. Calculations are going on in the background. The unique thing about this is what we call a one-way function. And the idea of a one-way function is easy to do in one direction, but it's either very hard or impossible to do in another direction. You might be like, well, I want to show you a math example of this. So this was a math class, and I said y equals x squared. I take this. This is a function, right? And if I said x equals 2, you could tell me that the y is going to equal 4 because 2 squared is 4. Only one answer, right? Easy. That works one way. What if I told you y is equal to 4? And I said, what does x equal? You might say, oh, then x equals 2. It could equal 2, but it could also equal negative 2 because negative 2 squared is also 4. So this is one of those cases where, hey, the function works one way when you plug in the x value, but plugging in the y value to find x, like doing it the reverse way, it doesn't give you one solution. So this is a case where, at least in the mathematical sense, where you can't always just take a function and go backwards and forwards and it works out fine. You might have multiple solutions, or it might be very hard to calculate. We can talk about math. If we get to crazier, math functions are hard to calculate. So for example, if I said, I could do like, if I said 5, okay, it said 5 to the, I don't know, 5 to the third power. And what's 5 to the third power? You can say, oh, it's going to be 125. But if I said, okay, these are bad examples. I'm not doing them. We talked about this before, that if you use like really complex numbers there, it's easier to do math one way, and it's just more complicated to do it the backwards way, just because the numbers are weirder to use. I can't come up with a good example on the fly, but I think that was the previous lesson. So that's what we mean by one-way functions. Either impossible with multiple options, or they're just take so long that it's basically impossible. You just can't do them fast enough. So the content or message you might need to authenticate or validate can be any type of data that represents on a computer. It could be a single file, could be a text, audio, video, whatever. Hashing data takes some input, a message, and it turns it into some hash thing. So because it's a one-way function, there are only two ways to recreate the input data. Yeah, the problem with this is I give you this sentence, I can use the hash formula to come up with this. But using this, it's very complicated to go backwards to this sentence. So it's one of those cases where it can't go backwards very easily. You can convert this way, but you cannot convert backwards very quickly. And it's just even for computers. So you can kind of brute force it by just like guessing a few things, or use a table of previously known values, but it's just very difficult for computers to do this. Ideal hash function algorithm used to create the hash is a cryptographic hash function, has 5 main properties. So it's deterministic there's a bunch of different hash functions. So it has to be deterministic, which means the same message always produces the same hash. So if you do that, it's going to always do the same thing, same hash. And it's a quick to compute because you want to be able to do that really quick. It is infeasible to reverse the hash and obtain the original message from its hash value, meaning it's just impossible, or it's like it just takes way too long. Go backwards. And a small change of the message should change the hash value. So if you go quick brown fox, it's this hash value. But if you go quick brown fob, change one character right there, it changes it to something else. So it's probably not going to just change one character. It might change a lot to it depending on how it calculates. And then it's going to have a unique hash for each unique piece of data. And they're unique just because you say, oh, how can 8 characters be unique? Well, there's a lot of different possibilities. When you have 8 bytes of data, you basically have this many different combinations possible. And that's a lot. But one solution, if you need more, you need a better hash function. There's probably some limitations here, is you can just have more characters in your hash function. So for our classes, that we're comparing two of these types of hash algorithms, MD5 and SHA1. The difference in here, MD5 has 128 bits, and SHA1 has 160 bits. So this is going to be bigger, and you'll see later in this lesson. Now, when it has more bits, and each, like 8 bits is 1 byte, right? When it has more bits, it'll be slower to process. It'll be slower to create this, but it'll be more secure because it just takes harder to break. It's harder to break because there's more options. There's more characters to go through. So there's your trade-offs. Let's see how this actually works. We're going to open this lab right here, and I'll go through these first few steps. So, you create a folder on the desktop and call it Hash Lab. All right, right-click Desktop, New Folder, Hash Lab. Now it's going to ask you to go to Windows System 32 and open Notepad exe. And you're like, why do I have to do it that way? You'll see later in the lesson. So open up C, go to Windows, and go to System 32 folder. System 32. And then we're going to open up Notepad. Like, oh gosh. We go down to Notepad. And right here. So I'm going to open this up, right? All right. So what I want to do is I'm going to create 3 files. And I'm going to name the first one, this is a test period, and call it test1. And then I'm going to make another file called this is a test exclamation mark, and call this test2. And I'm going to make a third file called this is a test period with a space after it, and name it test3. All right. So we're going to do all 3 of these, and let's see how this works. So we're going to call this is a test period. I'm going to file. I don't like my zoom. I'm going to go save as. We're going to go into that folder I created on the desktop. Call it test1. Just hit save. All right. And then I'm going to change this to exclamation mark. and say save as, and we're going to call it test2. And then I'm going to save, and then I'm going to change it to be period with a space at the end. And we're going to go save as and name it test3. These are text files. Boom. So they all have very minor changes. I just closed Notepad. I think I wasn't supposed to. Actually going to, okay, I think I fixed the resolution. Yeah. So you saved all 3 files. If you look in here, I have test 1, 2, and 3. If you want to see the extensions, I'm going to check file name extensions on the view tab just so show their text files, okay? And we save those 1, 2, 3. Now, what you're going to do in step 10 here is they had small differences. Now we're going to create an exact copy of the first file. So we're going to right click it and select copy and then paste and then call it copy 1. So you're going to go to this test 1 file, which if you double click it, it's just this is a test. You're going to right click this and go to copy. And then right click somewhere and go to paste. And we're going to rename this one copy 1.text. So it's an exact copy of this test 1. This is a test, period. The test of the period. Test 2 is exclamation. Test 3 is period with a space at the end. All right. Exact copy. All right. Now that we've done all this, we are going to get the hash values for these files. So step 11, we're going to open up the A422 files folder and open up hash my files. Go to activities in 422 and open up hash my files. It might take a second to do. So this is the part where it's interesting. So it's going to create like we had those algorithms, those 2 algorithms that we saw, the MD5 and SHA1. But we're going to go up to here. I think the steps are add folder, hash lab. Okay, I did this before. So you go up, you opened up this, right? You go to file and we go to add folder. We're going to hit the dots and then we're going to add the folder we created on our desktop. So we expand this and go to hash lab. Okay. So all 4 of those are up here. Now notice what it's doing right here, and I kind of expanded this. This is the MD5 algorithm, SHA1. Notice MD5 has this many characters, and SHA1 is going to be a little bit longer, right? Now, this also shows us a few different types of hashing algorithms. ERC32, SHA256, 512. Guess what? Those bigger numbers mean they have more characters. Like that's 256 bytes. This is just going to double the size. You know, hey, so if you want something to have more, to be harder to crack or harder to fake, I guess, or harder to brute force and prove it, you can make it longer, but it might take longer to create. There you go. We're going to focus on these 2. Things you might notice that I have this open now. So, okay, before we notice things, we're going to select all the files, and then we're going to save the selected items into a new file and call it A422 test on our desktop. So you can highlight everything or hit Control A. And we're going to say slave selected items, and we're going to go to our desktop, and we're going to say, I'm going to say my name, A422 test. Okay. So when you save that on the desktop, don't close that yet. It actually just saves all this information that's in there. It's just saving it in a format of all the information. One thing I didn't talk about is it also has information like the file size, the entry modified time, created time, modified, a full path of the file. So it's not just the hash files, it's all the other stuff about a file too. But now all that information is saved in this document as well. Now, why do we save it? I think we use it later. They say later in this activity, but I don't know if you do. I didn't do it last time. So let's answer some questions about this. So it asks this, based on the hash values, what can you tell about these files? And based on the other output. So here's one thing you might notice here. Remember how we notice these MD5 hash values are all different here? So test 33 is 88 DC, and then 702 ED, and then test 1 is 120 EA. I'm curious, I think those are exactly the same. Like if you guys made a file exactly like mine, those should be the same hash values. I think on your computers. I think from first period, because I think I remember this. I think they should be the same. So if you made a file that's a text file with the exact same characters as I created, they should be the same. Notice another thing in SHA is these are all different as well. We made a copy of test one right here, and the contents of it are exactly the same, and they have the same hash values, right? Identical hash values for all of these. Now, one thing to notice is that are the files identically the same? So the contents of the file is the same, but the file name is different. So one thing you might notice with that is the file name doesn't affect that hash value right there. At least how this stuff's calculated, right? Maybe other hashes actually keep track of the file name too. I don't know. You can also see modified time. So these entries, so these two, the second one, their copies actually was made like 2 minutes after the original. So they have different modified times, or the different entry modified times and different created by times, but that did not affect the hash values. Those are things you might notice as you work through this. Now 16 says download it to use for later use in the activity. I don't know if you need to. I didn't notice it, but maybe I missed some step. So to download again, you go to like open up File Explorer, go to G, and see this download. I'm just going to drag that file, download, and then it should download to your local machine. All right? It will be used later in your downloads folder, wherever that is. All right. Going to go to the next step, 17, data validation. No problem. If you show up late, just type in chat. Hashing can be used to provide data validation. For example, you calculate the hash of one piece of data, you can save it, then calculate the hash of the same piece of data at a later date. The hash value should match. Yeah. So if I have that file and download it to my local machine, or I check it the next day, the hash value shouldn't change. So its hash value is connected to the actual information in there. That's the data in the file. We're validating that data inside the file, not like characteristics like the name of the file or the time that it was created. If they do match, it tells you that the file is the same. If the hashes do not match, then something in the file has changed. So open your hash lab folder and open all 4 files. So I'm going to close all this. I think we don't need this. Maybe we do again. So I'm going to close all this. We're going to open all 4 files. Boom. Well, we can't open the 4. I don't care. Maybe I just do this on the side. Here we go. Notepad. Next one. Test 2. And test 3. All right, so if I have these all open, there we go. Okay, notice this one has the cursor going out farther. In at least 3 files, add a paragraph or 2 to the test sentences. So let's take 3 of those files and add a paragraph or 2. So I'm going to take this one. I'm just going to add stuff, hit Control S. Control S. I'm going to do it for the first 3. Control S. And then hit Control S. Right? I'm not going to change this one. It doesn't matter how much you add. You can just add some text. If you want to add a longer paragraph to prove this, go for it. And hash values. Now, so notice that, should have left hash values open. So, okay, my bad. So I'm going to have to pull this up again. So we won't see this. The idea for this next step is that I change those. And if I refresh my hash values, they should all change right here. All right. So maybe this won't be as interesting if I hit the refresh button right now. So I have to hit add folder, hash lab again. Notice I have these 3 files. Notice that copy and test are not the same anymore. In fact, I can actually pull up and reference the old thing. So copy 1, the MD5 hash file is 120E, but now it's 7ABF. And test 1 was 120E as well. Now it's A9C2. And test 2 is 702E, but now it's 443F, first 4 digits. And test 3 was 88DC. Now I didn't change it, and it's still 88DC. So I'm showing you that, hey, I changed those files, and now it changed the MD5. If I went in here again and changed this for just test 1 right here, I just saved it. And watch what happens when I hit the refresh button. Test 1 right here. Test 1, changed. Test one change. If I do this again, why did everything? I go that test one, boom, changed. What if I just added one character, E at the end? Control S to save. Changed like everything. It's just one character changed the whole hash value. I don't know how it's calculated. What if I just made this like a capital? I put a space at the end. Does it change it a lot? Yeah, changed everything. It's kind of crazy. It's like, think, oh, one character should just change one character on here. No, it's not how the calculations work. So they're a little bit more confusing than that, right? Otherwise it might be too easy to crack. If you can kind of reverse engineer. Like, how's that even working? I don't know. So, okay, so we did this. We made a change. We're going to say a hash of the folder and save the output as baseline. So we're going to save this as baseline right here. Save it. We're going to call it baseline on my desktop. I'm just going to call it baseline. I don't care for my name on it. And select one person in your cyber team. So if you're matched up with people, you can do it this way. But otherwise, you can follow along. To change two of your test files you just modified, the other member looks away while the first person makes the following changes. The one who makes the change can overwrite data with spaces and uncapitalize. Okay, so the point of all this, it should have, after you change the same number of characters before. So what they're doing here is, this part of the activity is like saying, hey, what if you just change one thing? And I think if you're not doing this with teams, the idea was like, oh, you just change this, maybe change that F. Like, it's the same number of characters, the same file size. I put a capital F right there, and you refresh it, and it changes. So that's what that part of that activity is about. And it's like, oh, let's someone change it, then turn away, and then notice it'll be different. But for purposes of this right now online, you can see one small change changed a bunch in there. All right. So that's the point of that part. So let's clear everything. I'm gonna hit this clear button, so nothing is left in here, and do this final part of the activity. We're going to create hash values for files in another folder. So click add folder, and we're going to add a folder in the Windows. Click add folder to add files from the Windows System 32 folder. So, okay, this is where it's, okay, we're going to go to a different parts. This is like going to show you closer to what people potentially could do to hack your machine. You're going to go to Windows, or to mess with you, Windows, and go System 32. That's where we found the notepad file, if you remember earlier. You can hit OK. Now this should take like a minute or two because there's a lot of stuff in there. So what we're going to do, and if you were in Teams right here, what we're going to do is we're going to change some of the files in your Windows System 32. And the idea with this is, if you're working with someone else, one person's going to do something with the files, then the other person's going to try to figure out what they did. All right. So if you're doing this, there's a hint right here for the other group. So what we're going to do is, basically we're going to swap the notepad, the name of notepad and the name of paint. We're going to swap those names around. All right. So, and then we're going to see what happens. What happens when you swap the names of those files around? So it's going to, like, if you look at the directory, they might look the same, but you'll be able to tell if the files are different because of the hash. And that's the idea behind this. So let's see how this actually works. All right, so here's everything in Windows System 32. There's a lot more files in here, but still, like, we're doing the same hashes, right? So the things that we're going to change, if we go into this, I'm going to close these out. Close all the things I don't need. I don't need all these things. I'm going to close all those. I'm going to go to Windows and System 32. The idea is I'm going to go to Notepad. Doesn't work. I just want it to go down to Notepad. Oh, you can just start typing Notepad. Oh, cool. If you ever just want to search things, just start typing it out when you click down here. I'm going to rename this to be Notepad 1 for now. Rename that, and then I'm going to type MS Paint. I'm going to change this one to Notepad. Well, first of all, I'm going to export all this. I think I want to export this all. It said I wanted to export it, right? Yeah, System 32. So before I go crazy, Rofi, baseline sys 32. Should have done that first. It didn't matter because I changed all these. So I changed that to Notepad. Now I'm going to go back to Notepad 1, change this guy to MS Paint. So, yay, so I have my MS Paint file. I changed those. Now, I think they're just not going to work. Like, Notepad's going to look like, okay, like they're not going to work right now. But you notice, like, the files are still there. I just changed the names. So, if I hit refresh right here, and so the other person would turn around. And how do you tell by looking at this? Let's say if we're looking at this list, how would I tell that things had changed? And this is a question for you, and this is where the activity is. Like, how can you tell something's changed? Well, we can tell by the hash values that things are changed. So if I went to my baseline here, what? Unable to create a new document. Oh, I screwed up. Okay, I probably screwed it up because I changed some of the files before. Whatever. The point of this activity is I changed those. It's going to change the hash values on here. And then the other question is like, well, how would you figure out, how would the other person who's not watching figure out who, like what file had changed? And this is kind of hard because there's a lot. Now, there's probably a way, and I think we haven't learned it in this lesson. I'm guessing it's coming in the next lesson. There's probably some automated way to like check hash values and compare and make sure what's changed and what hasn't, compared with names. But other information that would kind of give it away is like, you say modified time. Like what was just modified in the last 2 seconds or the last minute? Oh, these two. So I would look at modified times and I'd say, hey, look, that's been modified in the last, few minutes or whatever. And then I would compare these hash values. So my guess is this notepad exe hash value was not what it originally was in the original baseline, which got corrupted. But ideally I would go back and go, oh, hash value change. And actually this hash value was the original notepad and that one was the original paint. So you might see if you were doing this in person with or partner, they might be able to figure that one out. That's the point of that activity. We're done with this. Congratulations. See you next time.